Hi, Robert Cook here. Today we're going to be doing a video on real-time streaming of data and then doing user-solicited callbacks on that data. So really to show you how you can take your back-end applications and integrate them into AMI. So what we've got here on the left is we've got Chrome running our front end. On the upper right here, we've got our database, our in-memory database called AMIDB. You can go ahead and log into that and you'll see it looks like a normal database. Basically out of the box here, it's just got system tables. And then in the lower right, this is a PuTTY terminal, which is basically simulating what your application would be doing. Now we have client APIs that wrap this stuff, but I thought for this demo, I'd show you kind of bare metal what's going on here. So for example, if you use our AMI client.java and you call login on it, really it's generating a command that looks like this. So first thing is I'm logging in and I'm identifying my application's name as demo. So that's kind of my process name. So now, the first thing I'm going to do here is go ahead and log in on our front end. So now I'm going to go ahead and stream in a record. So I'm this back-end application. I'm going to stream in a new sample order. I hit enter. And now on this table up here, if I say show tables on this terminal up here, we're going to see that there's this new sample order table. Now, we'll also note that it says on undefined column, add. So what that means is if I, let's say, send in another record and it has an additional field on it, in this case status, and I submit that, now we're going to see that a status column shows up. So select star from sample order. We can see that it automatically created this additional column here. So basically this looks and feels like a very normal database. You run queries against it, all that fun stuff. Now the real interesting thing here, window, new window, create a real-time table, and I'm going to go ahead and put a real-time visualization on this table here. I'm not really interested. I want to have order ID up in the front, and I'm not really interested in these two columns, so I'm just going to go ahead and hide those guys just to make it a little bit cleaner here. So now we've got our order ID, price, quantity, status, and symbol. I'm just going to send in a few additional records here. There we go. And as soon as I do that, you can see it shows up on the front end. That's really nice. Now here's the thing is we want to be able to update records inside here as well. So first off, if I do that select star, we can see that shows up. If I said delete from sample order where, let's say, order ID equals 2. As soon as I do that, we're going to see it disappears from this table over here. And if I run the select, obviously it's gone from our database. Now we want to make updates happen automatically. So what I need to do is create an index on this. So I'm going to say create index I'll give it a name, on sample order, and the column that I want to create the index on, it's just going to be a single column. It could be composite, but in this case just a single column. And what I want to do is say use constraint equals primary. Now what's interesting that happens about this is now there's an index, first off, that speeds up searching if we search on order ID, but more importantly, this says that that's now a unique ID. So if we send in a record for the same ID, instead of creating a new entry, it's going to update that entry. So basically like an upsert. So let's go ahead here and say, I'm going to go ahead here and say for order ID 7, we're going to change the quantity from 7,000 to 8,000. So let me go ahead and prepare a record that looks like that. Okay, there we go. And now I'm going to enter this guy here. So object type equals sample order, order ID equals 7, and quantity equals 8,000. I'll do 80,000 just so it really shows up here. So now over here we can see it's set for a quantity of 7,000. I hit enter, and immediately we can see it jumps to 80,000. Now let's say we want to delete that record. Delete, and basically it's going to be very similar syntax, but now we don't need to give any values. They would more or less be ignored. But we could do sample order and then say order ID 7. So we do that, now it disappears, right? I'm going to go ahead and just put that order back here so we have a little bit more data to work with. Go ahead and put that back. There we go. So that's how you would update, insert, and delete data from your application. Very simple to do. Now the next thing we want to do is actually do a callback. Now this is a little bit more interesting. So first off, I'm going to say I want to register. I'm an application. I want to register a callback. And the ID for this callback will be, let's say, cancel. Something like that. Okay. Now, the next thing I do is hit enter, and I want to now set it up so that there's a button. And when I click that button, it cancels everything that's selected inside here. So I'm going to go ahead and add a new panel below this guy, below, submit that. And now I'm going to create an HTML panel, and I'm going to go ahead and just put a simple button inside there. Now the first thing I need to do is I want to grab the contents, the selected contents from this. So this is where we're going to get into some AMI script here. So I'm going to go ahead and grab panel 1. I want to get the contents from panel 1. That's going to create a variable called panel 1 of type panel. So now I can do panel 1 dot and then say as table. And now it gives me a bunch of options. What kind of rows do I want? Do I want selected, unselected, filtered, visible, hidden, so on and so forth. So I happen to know I want true, false, false, true, true. So this is going to create a table, and that table is going to have all of these selected records. It's not going to contain the unselected records nor the filtered records. It's going to have all visible columns and hidden columns. So this is just creating a temporary table that I can now play with. So for example, session.alert, if I just were to alert that table to the screen here, now let's say I run that test. So basically what comes back is you can see that the 3 records that are selected are now showing up in this temporary table. But I actually want to send this to the back end. This is where it gets interesting. Session dot call command, and I'm going to do call command sync. So what that says is for this script, it's going to send the command to the back end, and then it's going to wait for a response to come back from the front end, from the back end, sorry. So first thing I need to do here, looking at the signature, is I need to send in the app ID. That's going to be that demo that I sent in before. The command ID, which is going to be cancel, and then the table. So I'm going to say I want to send in demo. There we go. I'm going to send in cancel. There we go. And I'm going to send in the table. So it's that easy. So now the next thing I want to do is I want to put the response, the actual response, into something here. So we'll show that in a second here. Let's see here. One second. I just need to look up what that actually returns so I know. AMI script doc. This is good to do anyways here so you guys can see this. Class types. And now if I go down to my session, that's what we're calling this on, and I take a look here at callback command sync, that returns a command response object. That makes sense. So I'm going to create that command response CR equals. There we go. And then when we're done, we're going to alert that. Session.alert CR. Okay. So now what I'm going to do here on the back end is, well, I'm going to wait because on the front end, I'm going to go ahead and click that button. So I'm going to hit submit here. And now I'm going to hit the button, click. We can see that the back end has actually received a JSON message of arrays of maps. So each row is represented as an entry in the array. And then basically this map here represents that particular row. And we stuff that into the V variable. So you would grab that. Now I want to respond. So I'm going to response. And by the way, you'll see that it's waiting. So I didn't do any options, so it actually brings up this waiting screen. Now normally the backend should be responding nice and quick. So the user probably wouldn't even see this waiting thing. So response. So the first thing I need to do is respond on the request that came in. So this is a unique ID representing that request. And then I'm going to send back a status of 0. That means OK. And then I can send back other values like something equals 1, 2, 3. Something like that. Or let's do status equals OK, you canceled. So there we go. Now we can see that basically as soon as that response came back, we alerted that. Now I forgot what I need to do in the session.alert. Let's just make this a little bit better here. Instead of just printing out the whole command, I'm going to do cr.get return values. There we go. And by the way, you would normally take these return values. You know, this is now a map, so I could do this map m equals something like that. And now you could do something with that map, like grab values out of it and do some sort of user feedback, update values, whatever. Session.alert m. Right, so session.alert m, and that will be good enough. So now I will hit, and I'm going to comment out that alerting of the table. All right, so let's try this again here. I'm going to highlight 2 records, hit the button. We can see now it's sent a new command to the back end. I'm going to go ahead and respond to that particular command. And now I will go ahead and give my status again. There we go. Hit enter. and now it came back, and you can see the user saw status okay, you canceled. Now normally what would happen is we would probably send a bunch of cancellation statuses here as well. So for example, I might send in order type equals this, and then order ID equals 6, and then status equals canceled, CX. Right, so that updated that to CX, and you would normally do it, you would send this in for each, the backend app would send this in for each one of those rows. So, I'm not gonna sit here and manually do this, but that's it. In fact, I could also do it from the script inside here. So I'll go ahead and cheat. Update, sample order, set, status equals CX. And now we can see they're all updated to that. So that gives you a quick example of how you can basically send commands to the backend and then respond. Now, like I mentioned, generally you would use our client to do that. So instead of manually parsing this stuff, you'd use the client, but the principles are exactly the same. So just to recap what's happened here, I sent in real-time data. I then registered a command, right? I registered a command here, and then basically at that point, now the front end can start sending it back to me. Now, the interesting thing is the reason you have to register this command is because let's say there's multiple backends connecting into AMI. First off, each backend should have its own ID, and then it should also be registering its commands. So basically what AMI is doing when you run a command is it's trying to find the nearest relay or the nearest application that matches the application ID, which in this case is demo, and matches the command ID. And if it can't find a command, then it's going to give you an error back saying that that command is not registered anywhere and can't run it. So this works very, very well if you have lots of different applications that want to register themselves on the back end of your front end as services and then have those commands run. Okay, thank you. That's it for today.